So worksheet 11, everybody find it? Anybody need another copy? Good? Okay, operations with functions and composition of functions. The notation can be a little bit tricky for students, but in general, I don't think this is a hard lesson, except for the domain restrictions continue to trick people. Guys, what are the two things we talked about? Do you remember what? Domain is all real numbers unless there's some kind of a radical, an even powered radical. Whatever's underneath here has to be greater than or equal to 0. And then if there's an x in the denominator, whatever that denominator mass is, has to be greater than, cannot equal 0, just kidding, not greater than. Right? Those are the domain restrictions we have to worry about. Okay. When we do operations with functions, two separate functions, like an f of x and a g of x, can be added, subtracted, multiplied, or divided to form a new function. For the new function, the domain consists of the intersection of the domains of the two functions, excluding values that make denominator equal to 0. In other words, the domain is all those values of x common to the domains of the first two functions. So if they were both all real numbers, the new one's all real numbers unless there's a denominator. Okay? If the original function had a restriction, the new composition or added or subtracted function will also have that same restriction. Okay, that sounds all complicated. It's not as hard as it sounds. All right, this is just a different way of saying that domain business. Polynomial function without radicals is all real numbers, right? A function with a fraction within a variable, with a variable in the denominator. There's a variable in the denominator. If you set the bottom equal to 0, exclude the x value. If there's a variable inside a radical, set the terms inside the radical to greater than 0 and solve. Everybody good? Feel like this is, it's repeating. I just found this little graphic that explained it. All right. Operations with functions. This is the notation that you're going to see, but this is all it means, okay? F plus g of x means you take the function f of x and you add it to the function g of x, combining any like terms. F minus g of x is just take f of x minus g of x. Now, you'll have to watch your signs, right? Because if you have this and you're subtracting this, and this is one function and this is another, you're going to have to distribute the negative. You know what I'm talking about? Okay. F, now the filled in solid dot, guys, is multiplication. Okay. F times g of x, you just take f of x times g of x. If it was this function, you'd want to, FOIL it together, distribute. And sometimes they write it this way. They'll just write fg. That still just means to multiply. And these, both of those with this big solid dot or just right next to each other are not the same as the open circle. Do you remember? We're going to talk about the open circle in a minute. That means f of g, which means you put g into f. And this notation means the same as that one. All right, last one here is the denominator. F over g is the same. You just put the function f over the function g and make sure that g can't equal 0 because now it's in the denominator. All right. So here's a quick example. It says add these two, f and g. So they wrote down f, they wrote down g, they combined the like terms. The domain of the original was both all real numbers, so the new domain is still all real numbers. That seem okay? This is f over g. So they just wrote f on top of g. That seemed pretty easy. But then they factored to make sure there was no weirdness going on, and there is. You notice we're going to have a whole at -2 would be the example here when we get to that later in chapter 2. But for right now, what you need to know is you can cancel this, and this is the function. And the domain of these two, okay, were all real numbers. When you set them up before you simplified, x couldn't be -2. So the domain of this new function can't be -2 either, even though it's just a line. That's a weird one. Probably not going to put that on a test or quiz, to be real honest. Okay. If it didn't simplify, so you wound up with this. Oops, that was an x. Okay, if you factor the top, nothing's going to divide out. Okay. I would put this on the quiz because then I would expect you to say x cannot be -1. The part where it divided out, that was just made it harder. All right. Let's go through these together. I think they're blank for you to write down. F minus g would just be the same as f of x minus g of x. So what are we going to have? X squared minus 3 is f, and then we're going to subtract this, okay? What is the domain? Is there a restriction? Yes. X cannot be 0. And I'm okay with you writing this. Just because what's going to happen is on a quiz, it could ask you to find the function added, subtracted, multiplied, and divided. And if I ask all that, do you want to have to write interval notation for all those to tell me? So just do this, okay? It would be, if you were doing it, this. Everybody's okay with that? Everything but 0? But it's okay to just tell me x can't be 0. All right, this is a solid dot, so we're multiplying. So we have x squared minus 3 is being multiplied by 1 over x. I'm going to actually put it out in front because I'm going to distribute it. What would that look like? You'd have x squared times 1 over x minus 3 times 1 over x. What is this going to simplify to? Yeah, just an x. And back here, 3 over x. This would be okay. Could I have just written x squared minus 3 over x? Is that the same thing as this first one? Multiplied onto the top, right? Does this cancel? This is a sum on the top, right? So if you separate it, then you can reduce this one. But if you keep it together as one, you can't reduce it. All right. Either way, the domain restriction is x can't be 0. All right. So this is very similar to the last one. Can you try add, subtract, multiply, and divide for these two? Ooh, divide's looking kind of ugly. Anybody want to do one? What would f plus g look like? Nobody? When you add them, you just get what? Where x can't equal 0. Okay, minus. Anything complicated about that one? X squared minus 1 minus 2 over x, where x cannot equal 0. Everybody okay? What about times? How do you want to do times? Okay, so 2 over x, you want to distribute it? X squared minus 1. So we'd have 2x squared over x minus 2 over x, right? which would simplify to what? 2x minus 2 over x. Where x can't be 0. If you had written it as 2x squared minus 2 all over x, that's equivalent, and it doesn't simplify. Okay. If you want to leave it as one fraction instead of 2, I don't really care. What about the divide? The one we're all kind of scared of. X squared minus 1 is being divided by 2 over x. What does that mean? Okay. X squared minus 1 is being multiplied by what? X over 2. So you want to leave it as what? How do you want to write it? All over 2. So you want to distribute it and leave it like that? Okay, is there a domain restriction? You can't have something in the domain of the new function that wasn't in the domain of the old function. So what number wasn't in the domain of the old function? X could not be 0. So even though this has a domain that seems to be all real numbers, because one of the original functions excluded 0, it's still excluded. Let me go back to that first slide, just to go over that one more time. It says the domain consists of those values of x common to the domains of f and g. Okay, if g didn't have 0 in it, it's not common to both domains of the original functions, so it's still excluded. This is kind of how I think of it. The domain can't get bigger. Okay, you can't include things that it didn't include before. All right, that wasn't the slide I was on. This one? This could also be written separately as x cubed over 2 minus x over 2, but we all good? Okay, that one was f over g, just so the notes look nice. All right. Well, let's try it for this hot mess. Ugh. Well, anybody got adding? That's pretty easy. X squared plus 4x minus 7 plus the square root of x. Anything add together or simplify? What has to be true, though? It has to be greater than or equal to 0, because you can't take the square root of a negative number. Does that make sense? Did I write it wrong somewhere? It can't be less than. Yeah, it has to be greater than or equal to. Making sure I didn't write it wrong somewhere. So x is greater than or equal to 0. So you could write that like that notation or that notation. I would take either one. Okay. Anybody have f minus g? What changes, guys? Minus square root of x, and still x has to be greater than or equal to 0, or like this. You don't need both of those. You can write it this way or this way. Everybody okay? F times g kind of hurts my head. Anybody else? We have square root of x times all this. Is it, yeah. That's a good question. This should be plus. The only thing we subtracted was the g function. If it said g minus f, then we would have to distribute a negative through and all that. Yep, no, that was my bad. Thank you for catching me. Okay. If we distribute this, is it going to look any nicer than it currently does? Not really, so I would be okay with you just leaving it like that, honestly. If you distributed, you'd have x squared square roots of x plus 4x square roots of x minus 7 square roots of x. The restriction is still x has to be greater than or equal to 0, which could be written like that. But I'm okay with either one of these. There's and nothing simplifies if you just do it together. All right, what about the icky one we don't want to talk about? X squared plus 4x minus 7 over the square root of x. Well, if for the moment I were to let you leave it that way, what would the restriction be? What would the domain restriction be? Okay, how would we write it? Yeah, x has to be greater than 0. It cannot equal 0. So you could leave it like that, or you could do parentheses. It can't be 0, right? But it still can be, just adds one little number to the domain restriction. Kind of, sort of. I mean, I guess it really does only add one number. Anything else is okay. One less number to the domain. If I was really mean and said we had to rationalize this, does anyone know what that would look like? If we multiplied top and bottom by square root of x, we'd get a square root of x times that mess on the top, which you could distribute or not distribute, and then you just have an x in the denominator. I'm okay with this, I really am. All right. Composition of functions. Instead of using this notation that you might have used before, do you remember this? This means you put g into f, okay? You always do it inside out. It's going to look like this now. It's going to say put g, just read it backwards, into f, okay? And so sometimes you're going to see it looking like that, which means put f into g. So this is called a composition of functions. One is used to evaluate a second. Given f and g, f of g can be written like this or like this. The domain includes all x values in the domain of g for which g of x is in the domain of f. Oh, this hurts. I might have a slide explaining that better. So when you have put g into f, you have the domain of g and all the values for which that is okay to put it into g. Wait, domain of g. Domain of f has to come from the domain of g. And then it's in the domain of both, or the new f of g. In other words, it can't include things that weren't in the original function, basically. In the composition f of g, applied first, we already got that. All values in the domain of g that maps g of x values in the domain as shown. That's just really confusing. All right, so here's an example. This says, for this function, do this. Put the g into the f. So here's the g. We're supposed to put it into the f. So it became 3 times 4x plus 2 squared plus 2 times 4x plus 2 minus 1. Remember we had to FOIL that out first? Okay, that's where they got this. And then they distributed the 3. They didn't show a lot of work here. They distributed the 2 over here and got this, and then they combined all the like terms, which again, they didn't show much work. All right, later on, you're going to be asked to do things like this, f of g of 2. If they ask you to find f of g first, great. Then you just put 2 into the new function. But if I only ask you to find this value, you really don't need to find the function f of g. It's okay to put 2 into what first? G, and then take that answer and put it into f. Does this sound familiar? Okay. So you could really do this. Put a 2 into function g, and then that answer into f. And most of the time, that's less likely to have you make a mistake than to try to create the new function, unless you've already had to create it for another question. All right. So did I not do B for you on your paper? Okay. So this one says g of f of x. So what are we putting into what this time? F into g. So here's g, 4 blah plus 2. That's the g, and I'm supposed to put f into that spot. Would you have gotten that right? Remembered which one, how to put which one into which? Okay. What is this going to simplify to? (12x squared plus 8x minus 2? Is that what someone else got? Did I do anything silly? Any domain restrictions? All real numbers, still all real numbers, we're good. All right, so more practice. This says find f of g, find g of f, and then find f of g of 4. 3 things we have to do. All right, the first one is maybe the worst. No, not the worst, I don't think. Yeah, this one wants f of g, so we're putting this in here. That one's not so bad, right? 2 times x squared minus 2x minus 4, and then don't forget there was a plus 1 back here on the original function. How's that going to simplify? Who's got me? Ian, how's that simplify? I think so. Is that right, guys? Distribute this, get minus 8, then the plus 1 would be minus 7. Any restrictions? Okay. Any volunteers to try the other way? So we're going to have, instead of x squared right here, now we're going this way. So we're going to have a 2x plus 1 quantity squared minus 2 times 2x plus 1 minus 4. 2x plus 1 times 2x plus 1 . And then we're going to have to FOIL that together. And back here would be a minus 4x minus 2, and then the minus 4 on the back. Okay, what happens when I FOIL this together, anybody? Yep, there's a plus 2x and another plus 2x. Plus what? 1 times 1 on a good day is 1. I'm not going to simplify anything till we get to here. Now, if I simplify, what do I have left? 4x squared minus 5? No? One minus... Did you remember to distribute here so that you had a minus 2 right there? Did you find what you did, Alyssa? Any domain restrictions, guys? No? Okay. There is no radical or denominator, right? Okay. Now, what of f of g of 4? One way you could do it is just put a 4 into f of g right up here, if you're confident you've done that right. Is there another way, though? Yep, you could put 4 into the g first, So you'd have 4 squared minus 2 times 4 minus 4, which would be 16 minus 8 is 8, minus 4 is 4. And then put that answer into F. I got 9. Is that the same thing if we put it in here? (16 minus 7 is 9, right? Because this would be 32 minus 16 minus 7, which is 9. All right. So this equaled 9 if I write it all. We could have done either one. I would have probably done this one just because if I mess something up here, I'm not going to mess it up a second with this when I plug it back in. Oh, do I have to do another one? All right. Yeah, this is, yeah, it's not adding and subtracting this time, right? F of G. So what are we doing? Okay, so we're going to have 3 times 1 over x quantity squared minus 4. What would that look like? Three over x squared, yes, because this is 1 squared over x squared and then times 3 minus 4. And I'm okay if you leave it like that. Now, what can x not be? Everything else is okay though, right? No radical. It's okay to have a negative in the denominator, even though once you square it wouldn't be negative anyway, but all right. G of f. So what would that look like? That's actually easier to write. 1 over 3x squared minus 4, because we're doing all this into there. Okay. 3x squared minus 4 cannot equal 0. How do we solve that? Because the denominator can never equal 0. Yeah, I would say if we bring the 4 over and divide by 3, then what? Square root. So we get x cannot equal what? Well, square root of 4 over square root of 3. What's the square root of 4? 2, but we have a square root of 3 in the denominator. We can't leave there. And what else? What else? Plus or minus? Anybody remember in plus or minus? As we square rooted an x squared, right? All right, so if we multiply by square root of 3 over square root of 3, we get x cannot equal plus or minus 2 square roots of 3 over 3. That's a beautiful answer, isn't it? Would you like me to write it in interval notation? Yeah. I am really good with cannot equal plus or minus 2 square root of 3 over 3. But unfortunately, you do have to have the plus and the minus, and you need to rationalize it. Okay. We're not done, are we? What do they want us to do? 4 into G and then that into F? 4 into G would become what? 1/4, and then that into F. So 3 times 1/4 squared minus 4. 1/4 squared is what? 1/16 times 3 would be 3/16 minus 4. 64/16 would be -4, so it's -61/16. Some of you got that on the calculator, confirming my fraction work. Okay, I'm putting the 4 in I put it in here and then in here, but you could have also put it in here. Are you lost? Okay. I did it by putting the 4 into here first, so it became 1/4, okay? And then I put that answer in here, so 3 times 1/4 squared minus 4. 1/4 squared, square the top and the bottom, so you get 1/16. Times this 3, which is like a 3/1, so that it multiplies only to the top of the fraction, so you get 3/16. Minus 4, I rewrote 4 as common denominator, but you could have just done 3/16 minus 4, math, enter on your calculator. You're okay? Okay. You also could have plugged it in right here and done it on your calculator, Patrick. 3 divided by 4 squared minus 4, math, enter. Okay? Oh, joy. Okay. I'm worried about domain restrictions. Oh, okay. G into F. 4. This reads G is putting into F, right? So we have 4 square root of x plus 3 minus 2 on the back. The domain restriction is what? X plus 3 must be greater than or equal to. You can square root 0. Yep. Greater than or equal to 0, which means x must be greater than or equal to -3. So you could write it this way, but I'm okay with either one of those. And this is the mess. All right. This means f into g. So we have the square root of 4x minus 2 went in here, but there's a plus 3 on the back. So now what? What's it simplify to under there? 4x plus 1. So we would say that has to be greater than or equal to 0, which means what? Greater than or equal to -1/4? Did I skip too many steps? Now let me ask you this. Did we make the domain bigger than it was before? This was, the original domain was x plus 3 is greater than or equal to 0, so x is greater than or equal to -3. Did we restrict it further or make it bigger? This included everything from -3 on up. Now we're only including from -1/4 on up. As long as we made it smaller, we're good. You just can't make it bigger. We didn't. So this is correct, or -1/4 to infinity. All right, and then the last thing was f of g of 4. So if I put the 4 into g first, I'd have square root of 7, is that right? And then if I put that into f, I'd have 4 square roots of 7 minus 2, which if I had put the 4 into the first one up here, I would have got the same thing, 4 square roots of 7 minus 2. All right. I'm going to skip this one just because we've had enough fun, okay? Apparently not. I'm not. I think there's a little bit of an issue with this one. So the first one says do what? G into f. So it will be 1 over x squared minus 1 minus 1. What will that become? X squared minus 2. Now, I think the issue here is most of us are going to say x squared minus 2 cannot equal 0. X squared cannot equal 2. So x cannot equal plus or minus the square root of 2. Okay, but what was the original restriction? Can't equal 1 either. No, it's both. If it wasn't in the domain of the original function, it's not in the domain of the composition. Yes, because, no, it's only 1. Thank you. Yeah, back here, we said it couldn't equal 1. All right. Let's try the other way. Put this in here. Whew, what happens? 1 over x minus 1 quantity squared minus 1. I'm thinking this should not be on the quiz. What do you think? Okay, if you square the top, you get 1, yes? If you square the bottom, can we just for a minute leave it x minus 1 squared? Minus 1. So what can x not be? X can't be 1, right? That's what it couldn't be in the original one either. Now, could someone give me a different answer than this? 1 over x squared minus 2x plus 1 if you did some foiling fun. If you got a common denominator to add it into a single fraction. I don't think I want to put that on test or quiz because I don't want to grade all the possible ways you could write that. But I really am okay with this. All right, what about f of g of 4? If I put 4 into g, what do I get out? 15? Everybody okay? So then put 15 into f, and we get 1 over 14. Is that what would have happened if we put the 4 into this right here? 4 squared is 16 minus 2 is 14, 1 over 14. Okay. All right. This is on your homework. I don't know that you have this, do you? Okay. There's homework questions like this. There are 3 functions on this sheet. Let's just do a couple easy ones because you're supposed to know how to find these values from a graph, and that's gone well for some of you on quizzes, but not others. If it just said find f of 2, which function is f? Well, that's not going to go well. How about f of negative? I can't even do f of negative 2. Okay. How about h of 2? That's this function over here, right? And when x is 2, the y value is 0. Everybody all right? So if I asked you g of negative 3, you would tell me that's this green one. And at negative 3, it's at 1. Everybody okay? All right. So they're going to ask you some garbage like this. Okay, what does this mean? Find g of 2. So if I go to the green one to positive 2, I am at negative 4. And then they're going to say plug that into f. Yes, find f of negative 4. F of negative 4 is down here at negative 9. You think this is confusing? Wait till you see theirs in the book because they're like all on top of each other. So we can start with a warm-up on this tomorrow. Your homework, guys, is this. You're the best class ever. You act surprised when the bell rings. Nobody was watching the clock. It's awesome.